March 23, 1945. The Rhine River is dark, swollen, and unrelenting under the cold moonlight. Rain drizzles over the muddy western bank where hundreds of men crouch in silence. They are engineers, not infantry yet tonight. They are the first to face the enemy. Every sound matters. The distant thunder of German artillery, the metallic clink of steel panels being locked together, the thud of boots in soaked earth. Spotlights sweep the water. The moment they flicker, machine guns open from the far side, tracers slashing across the river. Men drop flat, then rise again. They keep working. Each piece of the bridge weighs half a ton, carried by hand, guided into place under fire. An officer yells, "Connect Section 9." No one looks up. The entire crossing depends on their rhythm build fast enough, and tanks will roll across by dawn. Hesitate and hundreds die on this bank. Tonight, under artillery and rain, engineers attempt the impossible to turn a raging river into a road. By the spring of 1944, the Allied advance across Europe had become a race against geography itself. The Nazis had built a fortress continent, and nature, with its rivers, valleys, and flooded plains, was Hitler's last line of defense. Every major river from the Seine to the Rhine stood like a steel gate barring the road to Germany. The problem was simple to state but brutal to solve. An army cannot fight if it cannot move. Tanks, trucks, artillery all needed bridges, and bridges were the first targets the Germans destroyed when retreating. Each demolition turned the next advance into a tactical nightmare. The Allies had speed, power, and manpower, but rivers brought them to a halt. In 1940, the Germans themselves had learned the same lesson in France. Back then, their engineers had laid pontoon bridges across the Meuse under air attack. Now, 4 years later, it was the Allies' turn, but their challenge was greater. The rivers were wider, the German defenses heavier, and the timetable shorter. Eisenhower's armies had to cross the rivers of Western Europe before winter slowed them again. The key would be engineering, and the answer had already been quietly built, not in a frontline factory, but in a small workshop in southern England. It was called the Bailey Bridge, invented by British civil servant Donald Bailey. It was an unassuming lattice of prefabricated steel panels, pins, and transoms, a design so modular that it could be carried in trucks, assembled by hand, and hold the weight of a tank within hours. It was light enough to be built without cranes, yet strong enough to span a 200-foot river under combat. The idea was revolutionary. Instead of waiting weeks for fixed bridges or heavy cranes, troops could build their own using manpower alone. Bailey had designed a system that transformed infantrymen into engineers, engineers into architects, and chaos into order. By 1943, as Allied armies landed in Italy, the Bailey Bridge had already proven its worth. Over the Volturno, the Rapido, and the Arno, it allowed armor to cross rivers where every conventional bridge had been blown apart. British, Canadian, and American engineers learned to work in total darkness, counting bolts by touch and aligning girders by instinct. But Europe's rivers were nothing like those in Italy. The rivers of northern France and Germany, the Seine, the Meuse, and above all the Rhine were deep, fast, and often under direct enemy observation. Crossing them meant more than construction. It meant survival under fire. Every engineer knew the stakes. If they failed, armored divisions would stall, infantry would be trapped on the near bank, and the enemy would regroup. If they succeeded, the entire Allied advance could roll forward like a tide that could not be stopped. Training intensified. In camps across Britain and France, units practiced rapid bridging, building a 200-foot Bailey Bridge in under 6 hours. They memorized procedures, timed every step, and rehearsed under simulated shell fire. Military engineers evolved into a hybrid force, part builder, part combat soldier. By late 1944, as the Allies broke out from Normandy and pushed toward Germany, these engineers became the most critical men on the battlefield. The term combat engineer was no longer symbolic, it was literal. They followed tanks into ruins, waded through freezing water, diffused mines, and built bridges while bullets struck the planks beside them. And as the Allied front lines reached the dense forests of the Ardennes and the floodplains beyond, a grim realization spread among commanders. The closer they came to Germany, the more rivers they would face. The final obstacle would be the Rhine itself, the legendary natural fortress. Nearly 400 meters wide in some places with steep banks and swift currents, it was backed by layers of artillery, machine gun nests, and anti-aircraft batteries. The Germans had wired its bridges for demolition, ready to blow them the moment the Allies approached. To reach Berlin, the Allies would have to cross it, not just once, but dozens of times in multiple sectors under constant enemy fire. The question was no longer if it could be done, but how fast it could be done. And as that question echoed through Allied headquarters, one answer kept surfacing: the insane bridge design conceived by Donald Bailey and perfected in blood and steel across Europe. By the winter of 1944, the Allied advance had stretched from the beaches of Normandy to the very borders of Germany. But momentum had slowed. Rivers had become walls of water guarded by machine guns and artillery, and each crossing demanded a new miracle of logistics. The Bailey Bridge had proven itself dozens of times since Normandy, but never under such conditions. The closer the Allies pushed toward the Reich, the more deliberate the German resistance became. Hitler had issued orders: no bridge intact, no crossing unhindered. Every retreating German unit left behind wrecked spans and booby-trapped embankments. For the engineers, that meant starting from zero over and over again. At Nijmegen, during Operation Market Garden in September 1944, British and American engineers faced one of the most dangerous crossings of the war. The Waal River was nearly half a kilometer wide, swept by fierce currents and directly observed by German guns. Paratroopers of the 82nd Airborne had captured the far bank. But without bridges, armor couldn't follow. Under relentless shell fire, engineers from the British XXX Corps began building pontoon bridges. Rafts ferried materials across as artillery thundered around them. They worked for 36 hours straight, sometimes waist-deep in icy water, while men fell beside them. When the bridge was finally complete, tanks rolled over it within minutes and the Rhine frontier opened ahead. Yet Market Garden also showed the limits of courage and design. The failure to secure the bridge at Arnhem left the northern front stalled. The lesson was painful but clear. Even the best bridge design couldn't fix flawed timing or poor coordination. From then on, every river crossing became a meticulously planned operation, a blend of engineering precision and battlefield chaos. Through late 1944 and into early 1945, the weather worsened. Rain turned roads to swamps, rivers to floods. Engineers had to improvise, constantly building approaches through mud, shoring up banks, and anchoring bridges against the violent current. The Bailey system's genius was its flexibility. The same modular parts could build a small footbridge or a span capable of carrying a Sherman tank. Supply chains became feats of organization. Thousands of tons of bridge components were pre-sorted and moved behind the lines. Truck convoys carried them to the front, guarded like ammunition. Engineers worked in rotating shifts, often building multiple bridges in sequence. As the Allies advanced deeper into the Rhineland in early 1945, new challenges emerged. German artillery targeted not just the crossings but the routes leading to them. Snipers picked off officers and bridge crews. Luftwaffe planes, though diminished, still strafed the rivers at night. To build meant to expose oneself. Many engineers considered it the most dangerous duty in the army. Still, they kept building. On February 23, 1945, the Roer River crossings began. Operation Grenade, the U.S. Ninth Army's assault demanded simultaneous bridging at multiple points. Engineers had to contend with deliberately flooded valleys, as German troops had opened the gates of upstream dams. In the darkness, they waded into chest-deep water to anchor floating bridge sections. The roar of the current drowned out commands. By dawn, the first tanks rolled across each one, testing the limits of human endurance and mechanical genius. The Bailey Bridge's modularity had turned out to be its greatest advantage. Under fire, parts could be replaced instantly. When sections collapsed under shell fire, engineers rebuilt them within hours. Each success added to the mythos of Allied engineering, a force that refused to halt no matter the destruction. Across the lines, German officers couldn't believe how fast the Allies kept moving. "It was madness," one captured Wehrmacht engineer recalled. "They built bridges faster than we could blow them." By March, only one natural barrier remained: the Rhine. Its symbolic and strategic importance was immense. Every major Allied general, Montgomery, Bradley, Patton, Simpson, prepared a plan for crossing it. The Germans knew this was the last stand. They destroyed every bridge as their troops retreated. leaving only the wreckage of steel spans hanging over the water. For the Allied engineers, the Rhine represented the culmination of every lesson learned since Normandy. They would have to build under artillery fire, assemble in darkness, and sustain the crossing for days against counterattacks. The insane design of the Bailey Bridge would now face its ultimate test not on blueprints, but in the firestorm of the last great obstacle before Berlin. Combat engineers were unlike any other soldiers on the Western Front. They didn't charge into battle with rifles raised. They carried steel girders, hammers, and cables, yet they often stood closer to death than the infantry they supported. During river crossings, they were the first to move and the last to retreat. Their mission demanded a brutal balance of focus and composure. Even under artillery bombardment, the work couldn't stop. If a section failed, the entire crossing failed. Every second mattered. Accounts from the Rhine and Roer crossings reveal the sheer human endurance behind the engineering triumphs. Men worked waist-deep in freezing water for hours, unable to feel their hands or legs. Spotlights and flares turned night into a stage of chaos. Bullets skipping across the river, shells exploding among piles of bridge panels. Private William Jones of the U.S. 249th Engineer Combat Battalion later recalled, "You'd hear the shells coming, but you couldn't move. If you ran, the bridge wouldn't get done. So we stayed. You just kept tightening bolts, pretending the explosions were far away." The engineers weren't alone. Medics, infantrymen, and even tank crews joined when manpower thinned. Each crossing became a collective struggle, a testament not to machines but to willpower. Men learned to trust not only their comrades but the steel beneath their boots, forged and assembled by their own hands. Behind every successful bridge stood the exhaustion, frostbite, and courage of hundreds of anonymous soldiers who built victory one panel at a time. Their courage wasn't loud or cinematic. It was measured in silence, persistence, and the refusal to stop working while the world exploded around them. The Bailey Bridge was not beautiful by design. It was beautiful by purpose. Each component, side panels, transoms, stringers, pins were standardized to exact tolerances. A section could be carried by 6 men, locked into place with a single pin and joined to another within minutes. The panels could be stacked to form multiple trusses for heavier loads, creating an almost limitless range of configurations. This simplicity hid immense genius. Donald Bailey's innovation wasn't in inventing a new material. It was in understanding how soldiers work under pressure. The system was designed to be foolproof. No special tools, no heavy machinery, no calculations required on the field. A manual and muscle were enough. Its greatest strength lay in its adaptability. Engineers could build a single-lane bridge for jeeps or a double-truss structure capable of carrying 40-ton tanks. If a span was hit, damaged sections were swapped instantly. Even in muddy, uneven terrain, modular base plates allowed quick stabilization. The Allies mass-produced thousands of these bridge components in Britain and America, shipping them to Europe in advance. It became an industrial symphony, and the entire continent's manufacturing capacity turned toward the art of movement. By late 1944, over 500,000 tons of Bailey equipment had been produced. It was said that Bailey bridging won the war as surely as radar or the Spitfire. German engineers, though skilled, lacked such modularity. Their bridges required cranes, detailed calculations, and stable ground luxuries rarely available on a collapsing front. Bailey's modular system, by contrast, thrived in chaos. It didn't need perfection, only determination. When the U.S. 17th Armored Engineer Battalion completed a 1,000-foot Bailey Bridge over the Rhine near Wesel, it took them just 36 hours, a feat previously thought impossible. Even as shells fell nearby, they continued. When one section collapsed, replacements were installed before dawn. In an age before computers or digital design, the Bailey Bridge embodied wartime brilliance technology made not for laboratories, but for muddy riverbanks where men fought time and fear in equal measure. Rivers had always shaped military history. From Caesar's crossings of the Rhine to Napoleon's wars, they served as natural fortresses, easy to defend, hard to attack. In 1944 to 45, they became the backbone of Germany's defensive strategy. The Allies learned quickly that seizing a bridge could decide an entire campaign. Normandy had taught them that logistics, not firepower, determined victory. Thus, bridging became as critical as artillery support or air superiority. Commanders like Omar Bradley and Bernard Montgomery treated engineers as frontline assets. not auxiliary forces. Plans for major offensives included exact bridge locations, load classifications, and assembly sequences all synchronized with armor and infantry movements. Tactical doctrine evolved around assault crossings. First came reconnaissance teams, often engineers themselves who scouted river widths, current speeds, and enemy positions. Then smoke screens were laid, artillery barrages began, and assault boats ferried the first troops across. As soon as the far bank was secured, bridging teams moved in sometimes while bullets still struck the water. Speed was everything. Every hour without a bridge meant stalled armor, exposed infantry, and lost initiative. At the Roer River, engineers built 8 major bridges in less than 72 hours, despite flooding and fire. At Nijmegen, tanks rolled across pontoon spans before the enemy could regroup. At the Rhine, entire divisions followed engineers within a single night. This doctrine of rapid bridging turned rivers from barriers into launch pads. Once considered choke points, waterways became channels of momentum, proof that tactical innovation could rewrite the rules of geography. By the final months of the war, German commanders realized the futility of relying on rivers. Their defenses could delay but not stop the Allied tide. The Bailey Bridge, that seemingly ordinary lattice of steel, had made every natural obstacle temporary. And yet, even as Allied engineers celebrated their success, the final test, the crossing of the Rhine, itself loomed ahead. The river that had defeated armies for centuries was about to meet the full force of Allied engineering. The success of every Allied crossing wasn't just a matter of engineering, it was a matter of trust. Senior commanders had to believe that bridges built under shellfire could carry entire armies across living rivers. That belief didn't come easily. Field Marshal Bernard Montgomery was one of the first high-level commanders to grasp the strategic potential of rapid bridging. During the planning for Operation Plunder, his crossing of the Rhine in March 1945, he treated engineers not as logistical staff, but as a combat arm. He demanded rehearsals, dummy bridge constructions, and precise timing. "The bridge is our victory," he declared, "not the tanks that will cross it." Montgomery's insistence on discipline and planning paid off. At Wesel, his engineers assembled a 1,000-foot Bailey Bridge under artillery fire, while artillery and smoke provided cover. The operation unfolded like clockwork, proving that engineering precision could match military choreography. In contrast, General George S. Patton approached bridging as he did battle with audacity. When his Third Army reached the Moselle and later the Rhine, he pressed his engineers to act before orders arrived. His mindset was clear: take the river before the enemy knows we're there. His confidence in the Bailey system was absolute. Patton once told his staff, half-jokingly, "Give me Bailey panels and I'll cross the Atlantic." Omar Bradley and William Simpson, more methodical by nature, recognized bridging as the key to sustaining the momentum of the U.S. 1st and 9th Armies. Their planning for Operation Grenade along the Roer required exact synchronization between dam control, infantry assault, and bridge assembly. Bradley's headquarters tracked bridge completion times as closely as enemy movements. Leadership in these operations meant making peace with uncertainty. Every commander knew that a single destroyed bridge could halt an entire corps. Trusting their engineers became an act of strategic faith, not in luck, but in human skill and steel design. And when the bridges held as they almost always did, that faith became part of the Allied command doctrine: speed through engineering. Across the river, German engineers were fighting a different kind of war, one of destruction. By early 1945, the Wehrmacht's engineering corps, once among the most skilled in Europe, had been reduced by attrition and shortages. Their mission now was grim: delay the Allies at any cost. They wired every bridge, flooded every valley, and mined every possible crossing point. Their work was a combination of technical brilliance and strategic despair. The Germans were experts at demolition. They could destroy a steel span in seconds, creating obstacles that took days to replace. But they underestimated the Allies' capacity to improvise. Even when bridges fell into the Rhine, the Allies rebuilt them with Bailey components faster than the Germans could retreat. In many cases, the German defensive doctrine backfired. By destroying fixed bridges too early, they denied their own retreat routes. During the fighting around Remagen, retreating units found themselves trapped when the Ludendorff Bridge unexpectedly held longer than planned. German engineers also faced logistical collapse. Fuel shortages limited demolition explosives, transport vehicles were scarce, and constant air attacks crippled their ability to reinforce positions. By March 1945, the Luftwaffe could no longer protect the Rhine's crossings. Allied aircraft hunted any movement near the riverbanks. Still, German resistance was fierce. Artillery batteries zeroed in on Allied bridging sites with deadly precision. Every daylight construction became a duel between accuracy and endurance. Yet even as they scored direct hits, the Germans found themselves facing an adversary that simply refused to stop building. One captured German colonel remarked after the war, "We had seen engineers. Yes, but never engineers who built under fire as if the shells didn't exist." The bridge war had turned the Rhine into more than a line on the map. It was a contest of endurance, the German will to destroy against the Allied will to rebuild. Among the soldiers who crossed the rivers of Europe, one sentiment appeared again and again in diaries and letters. They trusted the bridge. That trust was not just in the design, it was in the men who built it. Infantrymen who had once doubted engineers now saw them as saviors. After days of being pinned on one side of a river, the appearance of a Bailey Bridge meant life, progress, and survival. For the engineers themselves, morale came from creation amid destruction. While artillerymen and infantry tore down enemy positions, engineers built. Each completed bridge was a small victory against chaos, a defiance of nature and war. Psychologists studying post-war accounts noted how engineers developed a unique mindset, calm under fire, methodical despite horror. Many described the act of construction as a form of focus, a mental barrier against fear. "You stop hearing the shells," one British sapper recalled. "And all that exists is the next bolt, the next girder, the next span." The Bailey Bridge became a symbol of Allied ingenuity, proof that discipline and design could overcome even the most brutal circumstances. Soldiers joked that it was the bridge that won the war, but beneath the humor was reverence. When tanks thundered across freshly built spans, men would pause for a moment, listening to the rhythmic clatter of treads on steel, a sound that meant the front was moving again. For commanders, it represented progress. For engineers, it was pride. For soldiers waiting to cross, it was hope. By the time Allied armies reached the Rhine, this faith had hardened into doctrine. Bridging wasn't just an engineering operation, it was a psychological weapon. It told every man in uniform that nothing, not even nature itself, could stop their advance. And as that mindset spread through the ranks, the stage was set for the war's defining act of engineering courage, the crossing of the Rhine under fire, against all odds. By early March 1945, the Rhine, that ancient boundary of Germany, lay ahead like a final curtain of water and smoke. To the German people, it was a symbol of protection. To the Allies, it was the last wall before victory. For months, commanders had planned the assault. Eisenhower wanted multiple crossings along a 300-mile front to prevent the enemy from concentrating defenses. Montgomery would strike in the north at Wesel under Operation Plunder, supported by airborne drops under Operation Varsity. In the center, Bradley's 12th Army Group prepared crossings near Remagen, Bonn, and Oppenheim. Patton's 3rd Army, further south, waited to dash forward once an opening appeared. The enemy knew what was coming. Along the Rhine's east bank, German engineers demolished every major bridge, leaving nothing but twisted steel. Artillery positions watched the western shore day and night. Machine gun nests, minefields, and anti-tank ditches turned every approach into a killing zone. And yet, fate intervened. On March 7, 1945, a patrol from the U.S. 9th Armored Division approached the small town of Remagen, south of Bonn. Through binoculars, they saw something unbelievable, the Ludendorff Bridge still standing. Smoke drifted from its far end where German engineers had attempted demolition but failed. Charges had misfired. The bridge was damaged but intact. The moment was electric. Major General John W. Leonard and Brigadier General William Hogue had seconds to decide. The bridge was rigged to blow. Enemy snipers watched from the far bank, and the entire structure could collapse at any moment. But if they seized it, the Allies would have their first bridgehead across the Rhine. The order came. Take the bridge. Infantry from the 27th Armored Infantry Battalion sprinted toward it. Machine guns opened from the far shore. Explosions echoed beneath the decking as German engineers tried again to detonate the remaining charges, but the blast only damaged sections. failing to destroy it. American soldiers dashed across, dodging debris and sniper fire, securing the eastern bank within minutes. It was one of the most audacious moments of the war. Within an hour, combat engineers arrived. They had no time for celebration. The Ludendorff Bridge trembled under artillery hits, but they had to reinforce it fast. Using Bailey Bridge components, they patched shattered spans, bolted reinforcement trusses, and began building parallel pontoon bridges as backups. German artillery zeroed in. Shells rained down from the high ground across the river. The engineers kept working. Some were blown into the water. Others replaced them instantly. Their focus was absolute tighten pin, reinforce, repeat. By nightfall, tanks of the U.S. 9th Armored Division were rumbling across the bridge, the first armored vehicles to cross the Rhine into Germany. Eisenhower himself called it one of those rare and shining moments in history. News of the Remagen crossing stunned both sides. Allied commanders moved swiftly to exploit it. Bradley ordered supplies and reinforcements to pour through the bridgehead. Within 24 hours, thousands of troops had crossed. German counterattacks, including jet aircraft strikes, failed to dislodge them. For the engineers, it was a race against collapse. The Ludendorff Bridge had taken too much damage. Massive Bailey trusses were added to brace its main span. Pontoon bridges rose alongside floating structures built entirely by hand, lashed together under fire. On March 17th, after 10 days of relentless strain and shelling, the Ludendorff Bridge finally gave way, collapsing into the river. 28 engineers died, many swept away by the current. But by then their work was done. 5 alternate bridges already carried men and armor across. The bridge had fulfilled its purpose. At the same time, far to the north, Montgomery's Operation Plunder began. On the night of March 23-24, the Rhine exploded with sound artillery barrages, flares, and the thunder of engines. Under cover of darkness, thousands of assault boats pushed off, ferrying troops of the British Second Army and U.S. 9th Army across the wide river. Behind them, hundreds of engineers waited with Bailey panels stacked in the mud. As soon as the first wave secured the far bank, they moved in. Tractors dragged pontoons to the water's edge. Men carried steel sections on their shoulders, locking them together in rhythmic sequence. Each clang of a pin echoed through the night like a heartbeat. German guns opened up from across the river. Shells churned the water, scattering boats. Some engineers were killed instantly. Others dragged bridge parts through the mud, refusing to stop. Smoke screens rolled in to obscure their movements, but visibility was near zero. Still, the structure took form, one bay, then another, then another. By dawn, the first bridge was complete. Before noon, the second followed. By evening, tanks and trucks were crossing in an unbroken line, the bridge shuddering under the weight of entire divisions. Observers watching from the air couldn't believe the speed. One RAF officer wrote, "It was as if a bridge simply rose out of the river overnight." This was the culmination of everything the Allies had learned, the merging of courage, technology, and precision. Rivers that had once been natural fortresses now served as stepping stones into the heart of Germany. The Rhine, once the unbreachable line of defense, had been crossed not by luck or overwhelming firepower, but by engineers with wrenches and pins, building history under fire. The crossing of the Rhine did not end the danger. It began a new kind of battle. Now that Allied troops stood on the eastern bank, the mission was to hold the bridges at any cost. German artillery units, positioned along the high ground east of the river, poured relentless fire on every crossing site. Day and night, shells whistled over the water, seeking to destroy the newly built bridges before reinforcements could solidify the foothold. Engineers, exhausted and sleep-deprived, stayed at their posts. They patched holes, replaced panels, and strengthened anchors, each explosion undoing hours of work. At Remagen, the U.S. engineers had already expected this. They'd reinforced the bridge with Bailey sections and heavy cables, while amphibious pontoons ferried supplies as backups. Despite continuous shelling and Luftwaffe bombing runs, the crossing never closed for more than a few hours at a time. When the Ludendorff Bridge finally collapsed on March 17, 1945, it was not a defeat, it was a transition. By then, 5 alternate spans stretched across the Rhine near Remagen. One Bailey Bridge, codenamed Victory Bridge, carried tanks while floating pontoons handled trucks and infantry. The flow of men and materials continued unbroken. In all, the engineers of the U.S. First Army built 10 bridges across the Rhine in that sector alone within 3 weeks. Each was assembled under fire, often at night, and each became a vital artery feeding the Allied thrust into central Germany. Further north, Montgomery's Operation Plunder had turned into a masterclass of coordination. The combination of precise planning and engineering discipline produced results even faster than expected. Within 24 hours, 3 major bridges were operational, a record unmatched in modern warfare. On the British front, the Royal Engineers worked beside American and Canadian units, building bridge after bridge as the assault expanded. The Treadway Bridge at Wesel, one of the largest floating bridges ever constructed under combat, stretched over 200 feet across the Rhine's swift current. It carried more than 70,000 vehicles in the first 5 days alone. German counterattacks came in waves of artillery, mortars, even the first operational V-2 rockets targeted bridgeheads. But by this stage of the war, German firepower could not match Allied resilience. Every bridge hit was repaired, every gap filled. Engineers worked knee-deep in water, often using their bare hands to align damaged sections. Patton's Third Army crossed further south with characteristic speed. On March 22nd, without waiting for orders, he launched his own crossing near Oppenheim. Under cover of darkness, engineers from the 5th Infantry Division rowed assault boats silently across the Rhine. By morning, they held the opposite bank. Within hours, Bailey Bridge components were trucked forward. Patton himself waded into the river to inspect the work, grinning as the first tanks rumbled across. He later sent Eisenhower a now famous message. "Dear Ike, I have crossed the Rhine." The crossings had become symbols not just of tactical success, but of momentum. The German army, once unyielding, was now fighting on borrowed time. Every bridge that rose from the Rhine carried not just vehicles and supplies, but the end of the war itself. Still, the price was immense. Engineering units suffered some of the highest non-infantry casualty rates of the campaign. The 291st Engineer Combat Battalion, for instance, lost nearly a third of its men during the Rhine operation, killed or wounded while building. Many had no chance to take cover. They worked exposed, silhouetted against the river, illuminated by the fires of war. Their heroism was recognized quietly. Few medals were awarded on the spot. Most came later, after the bridges stood firm and the armies had moved on. To the engineers, recognition mattered less than completion. The bridge once built spoke for itself. Across the Rhine, the German command descended into chaos. The failure to destroy the bridges at Remagen and Wesel shattered morale. Hitler ordered court-martials of officers who had allowed such crossings, even though most had fought to the last. Entire divisions were now cut off between the Rhine and the Ruhr. Allied armor fanned out from the bridgeheads, encircling what remained of the Wehrmacht's western forces. By early April, the result was inevitable. The Rhine, once the centerpiece of German defensive strategy, had become an Allied supply route. Trains, trucks, and fuel convoys moved across the same waterway that had once symbolized German invincibility. From that point onward, the road to Berlin lay open. The Rhine crossings had done more than breach a river. They had destroyed the myth of the Reich's last sanctuary. The war in Western Europe was now measured not in miles of advance, but in days remaining. In the ruins of the western towns, Allied commanders reflected on what had made it possible. It was not just overwhelming force or air superiority. It was preparation, precision, and the courage of the men who refused to stop working under fire. The Rhine had been crossed, and the Allies had proved that no obstacle, natural or man-made, could halt a disciplined, determined army backed by the minds of its engineers. When the guns finally began to fall silent west of the Elbe, the enormity of what the Allied engineers had done started to sink in. Across northern and western Germany, rivers that had once been barriers now carried bridges in every direction, steel skeletons connecting two worlds, one of war and one of liberation. In just 6 weeks following the first crossings, the Allied armies constructed over 300 major bridges across German waterways. Bailey bridges spanned everything from narrow canals to broad rivers, forming an unbroken chain of mobility that stretched hundreds of miles. The speed of advance astonished even the generals. General Omar Bradley later wrote, Without the engineers and their bridges, our armies would have stopped at the Rhine and waited for the war to end without us. Those bridges kept the front alive. They carried not only tanks and artillery, but also ambulances, fuel trucks, food convoys, and mobile hospitals. The war's final logistics miracle unfolded across these trembling spans of steel. Statistics tell part of the story. Over 5,000 Bailey Bridge units were used in Western Europe during 1944-45. Allied engineers built or repaired more than 2,000 miles of roads and bridges in Germany alone. The average Bailey bridge was assembled in under 12 hours, often under shell fire. Each could bear up to 70 tons, enough for the heaviest Allied tanks. But numbers can't capture the humanity behind them. On the Rhine's banks, where the air still smelled of oil and smoke, soldiers remembered the men who had worked through the bombardments, their faces blackened by soot, their uniforms torn from shrapnel. Many engineers never saw the results of their labor. They were killed before the first tank crossed. In towns like Remagen, Wesel, and Oppenheim, local civilians emerged after the fighting to find entire floating highways stretching across their rivers. To them, the bridges were symbols of both destruction and salvation wreckage, giving birth to movement, to liberation. The engineers' work was tireless even after the crossings. Maintaining the bridges became a 24-hour duty. Constant traffic and vibrations loosened bolts, damaged decking, and wore out trusses. Engineers stood guard beside their creations, tightening connections, replacing panels, and directing convoys. Many soldiers described the sound of the Bailey Bridge as an unforgettable deep metallic rhythm, echoing with every tank tread and truck wheel. It was the heartbeat of victory, one Canadian sapper said. Recognition came slowly. Engineers rarely made the headlines. They didn't take cities or capture generals. They built the means for others to do so. Yet within military circles, their reputation soared. Commanders across the Allied armies credited the Bailey Bridge and its crews with shortening the war by months. Donald Bailey himself, working quietly in the British War Office, was knighted by King George VI in 1946. He later admitted that he had never imagined his design would carry so much of Europe's future. It was meant to be temporary, he said, but it carried the weight of history. In the U.S. Army, engineering units received Presidential Unit citations for their role at Remagen, Wesel, and Oppenheim. Many of those men would go on to rebuild bridges in post-war Germany, this time for peace. The collapse of the Rhine defense line marked the psychological end of Hitler's war in the West. Within a month, Allied divisions had crossed the Elbe and linked with Soviet forces advancing from the east. The river that once symbolized Germany's might had become the pathway of its defeat. As April 1945 turned to May, engineers who had risked their lives at the Rhine were already at work again, repairing roads, clearing mines, and erecting makeshift spans over the Elbe and the Weser to bring refugees and supplies through. Their war had no front lines, no parades, no flag-raising moments. Yet it was their discipline, the quiet persistence of building in the middle of destruction that made every triumph possible. And even as the thunder of guns faded, the echoes of those bridges remained steel reminders that courage is not always loud, and victory is not always won by those who fire the last shot, but by those who make it possible for others to move forward. When the smoke cleared over Europe, the same engineers who had once built bridges under fire were now asked to build a continent back from ruin. Their tools didn't change, only their purpose did. The Bailey Bridge, conceived in war, became the backbone of peace. In the immediate aftermath of Germany's surrender, thousands of damaged bridges lay in rubble. Civilians were stranded, transport routes cut, cities isolated. The fastest way to reconnect them was not through heavy industrial reconstruction. It was through Bailey bridges across France, the Netherlands, Belgium, and Germany. Allied engineer units reassembled the same steel panels they had carried through battle, now to rebuild rather than to invade. Bailey bridges appeared in every direction, spanning rivers, valleys, and bombed-out streets. Some were temporary, others remained in service for decades. The design's influence spread far beyond Europe. During the Korean War, Bailey bridges were once again deployed by UN forces to maintain mobility across rugged terrain. In Vietnam, modular bridging inspired by Bailey's design allowed convoys to move through jungle rivers under constant attack. Even in peacetime, the system became a lifeline. Used in flood relief operations in India, Pakistan, and the Philippines, in earthquake recovery across Italy and Japan, and in modern disaster engineering worldwide. By the 1950s, Bailey Bridge had become a generic term, not just a product name, but a concept. Portable, modular, indestructible. Civil engineers studied it as a model for rapid deployment under crisis. Military academies taught it as a case study in the union of simplicity and strength. Its legacy was not just technical, but philosophical. Bailey's design proved that flexibility could be stronger than rigidity, and that the ability to adapt under pressure was as vital in engineering as in battle. That principle influenced post-war bridge design globally, leading to modular construction techniques still used today in both military and civilian projects. In many countries recovering from occupation, Bailey bridges became monuments in their own right. Dutch towns preserved sections of the original wartime spans, painting them in peacetime colors. In Normandy, remnants still stand over quiet streams, silent witnesses to the days when steel and courage crossed together. In Germany, local councils left plaques where temporary Bailey bridges had once stood, honoring not only the liberators but the builders. Donald Bailey himself returned to civilian engineering after the war, rarely speaking of his creation's wartime fame. When asked about its enduring use, he simply replied, "It worked because it had to." For the soldiers who built them, that phrase carried deeper meaning. In their eyes, the bridges symbolized something more than engineering. They represented purpose. Amid the chaos of artillery and death, to build was an act of defiance. To bridge a river was to prove that destruction was not the final word. Modern militaries still rely on the same principle. Today's mobile bridging systems, whether built of aluminum alloys or carbon composites, trace their lineage directly to Bailey's wartime blueprint. NATO manuals still reference his modular system as the foundation of rapid field bridging doctrine. In the post-war decades, some of the very men who had built Bailey bridges in 1944 went on to design Europe's post-war infrastructure. Highways, rail lines, and permanent spans across the same rivers they had once crossed under fire. Their wartime precision, discipline, and resilience carried over into the reconstruction that defined a generation. And in many ways, the Bailey Bridge never truly left the battlefield. In the 21st century, its descendants still serve in military operations and humanitarian crises. From Afghanistan to flood-stricken villages in Southeast Asia, its panels, often the very same ones forged during World War II, continue to be used. 80 years after its first assembly on a rain-soaked English field, the Bailey Bridge stands not just as an artifact of war, but as a symbol of humanity's ability to connect rather than destroy. It was born in the shadow of war, tested in the fire of the Rhine, and survived to become a quiet bridge between worlds, between what was lost and what could be rebuilt. The roar of engines is gone now. The rivers that once flamed with artillery lie silent, flowing beneath bridges that no longer shake under tank treads. Yet if one stands on the Rhine at dawn, where mist drifts low over the water, the ghosts of that spring in 1945 still seem to linger. War often remembers the generals, the battles, the weapons that were destroyed, but rarely the men who built. The combat engineers of World War II did not fight for glory. They built under fire, measured victory not in enemy dead but in meters of steel joined together, in the moment when the first soldier stepped safely to the far side. Their bridges were more than structures. They were statements, proof that human resolve could turn rivers into roads, chaos into progress. The so-called insane bridge design was never madness. It was a genius born of necessity, an act of faith and reason amid destruction. Donald Bailey's invention, modular, simple, unbreakable, became a metaphor for the Allied spirit itself. Adaptable, determined, built to endure. When the war ended, the Bailey bridges remained, carrying not just vehicles but memory. Every panel bore the mark of men who had chosen creation over fear, order over collapse. Their work outlived the empires they served, the uniforms they wore, even the nations they crossed for. History often measures triumph by the ground gained. But sometimes the truest victories are those that hold the ground together, the ones that connect instead of divide. So when the rivers of Europe run quietly beneath their steel lattices, they whisper a reminder from another age that courage can build as fiercely as it can fight. that the bridge between destruction and deliverance is built by human hands, and that, in the darkest hours of war, the greatest act of strength is not to cross first, but to build the way across.